Good morning, students. So today we are again going to start with chapter 4, light energy, and our topic is constituent colors of white light from the sun. If white light from the sun is seen through a glass prism, it splits into its constituent colors and rainbow type pattern is seen. The prominent colors of white light are: first is violet, second is indigo, third is blue, fourth is green, fifth is yellow, sixth is orange, and the seventh one is the red. And these colors can be remembered in the order by the word Vibgyor. So let's see an experiment that how this is performing. Now let us take an example of refracting of light in a prism. When a light ray enters one refracting surfaces of the prism, it bends towards the normal, and when it emerges out of the other refracting surface, it bends away from the normal. It is a solid structure having a 3 rectangular surface and 2 triangular surface. Any 2 rectangular faces are the refracting surface and the third one is the base. The angle between the refracting surface is the angle of prism. The edge formed by the 2 refracting surface is the refracting edges. Now you can see that the white light is passing through the prism and the 7 color is coming out after the refraction. So the angle between the incident ray and the emergent ray is the angle of refraction. The phenomena of splitting of white light into constituent 7 color on passing through a glass prism is called the dispersion of light, and those are Vibgyor, means violet, indigo, blue, green, yellow, orange and red. As you can see, the rainbow is the natural phenomena in which dispersion takes place, and the cause of dispersion is that sunlight constitutes of 7 colors and they have different wavelength. Okay, so I hope you have understood what is the constituent colors of white light from the sun. Let us see what are secondary colors. Secondary colors are the colors of light which are obtained by mixing 2 primary colors together. These are yellow, cyan, third is magenta. If red and green lights are projected on a white screen, yellow light is obtained. You can see that when red is mixed with the green color, it is giving you a yellow color. You can again perform this thing at your home. It's a very simple experiment. If green and blue lights are projected a white screen, cyan or a peacock blue, that is called, is obtained. Means green plus blue is equals to cyan. Means a peacock color blue is obtained. Okay. If blue and red lights are projected on a white screen, we get magenta or purple light. Thus, blue plus red is equals to magenta. Thus, secondary colors are yellow, cyan and magenta. The following table summarizes the primary and the secondary colors. Primary colors are blue, green, red, and secondary colors are yellow, which is means made by mixing 2 colors, red and green, cyan, green plus blue, magenta, blue plus red. This is forming after the mixing of the primary colors. A color TV or a computer screen has an array of tiny spots. Each spot is composed of the 3 phosphor dots corresponding to the primary colors. red, green and blue. The color seen on the screen are due to combination of these primary colors. The effects of mixing of primary colors is shown, in which Y stands for yellow, C for cyan, M for magenta and W for white. You can able to see. Again I am telling you, this is a very simple and easy experiment or activity, we can say that, and you may see and you can even perform in your houses, that whether it is giving or not. So red plus green equals to yellow, green plus blue, cyan, blue plus red, magenta, and red plus green plus blue is giving you a white light. Clear? Now let us see the subtraction of colors. A transparent object allows the light of a certain color to pass through it and observes the light of rest of the color. Its color is the color of light that it passes through it. Means, again let us see, a transparent object means through which a light can easily pass through it, allows the light of a certain color to pass through it and observe the light of rest of the colors, and its color is the color of light that it passes through it. For example, a red cellophane paper passes only the red light through it. A blue cellophane paper passes the light of only blue color through it, and rest of the 7 color is observed, okay, when the white light is passing through a cellophane paper which is red in color. Rest of the light is observed in it, okay, and it allows only that colors of which the material is. Okay, now let's see forward. Color of an opaque object. Opaque object means through which the light cannot pass. For example, it is written that when white light or sunlight falls on an opaque object, it reflects the light of some colors and observes the light of rest of the color. The color of an opaque object is the color of light which it reflects and that reaches our eyes. If the body reflects light of all the color, it appears white. That is your case 1. And in case 2, if the body reflects none of the color, it absorbs the light of all the color and it appears black. And this is the reason of forming of the shadow also. Okay, when you are standing in front of the sunlight, means the sun is behind your back, so your shadow is forming front, okay, and when the sun is rising, in that condition your shadow is always at your back, okay. This is the reason how the shadow is forming, because your body is an opaque object which absorb all kinds of light and the shadow is black in color. Thus a red object will reflect only the red light, a blue object will reflect only the blue light, and so on. Clear? Now example, a piece of paper appears white in sunlight because it reflects light of all the colors, okay. A red rose appears red in white light because it reflects the light of red color and observe the light of rest of the colors. Leaves appear green in white light because they reflect only the green light and observe light of all the colors, okay. If a red rose is seen in a green light, it appears black, okay. Why? Because green light and red color, when it is mixed, it is giving you a black. So The reason is that the rose absorbs the green light and falling on it and reflects none. Clear? If a red rose is seen in red light, it appears bright red. This is because the rose reflects the light falling on it and observe none of it. Because the red light is only falling, so there is no need of observing, and this is the reason why the rose, which is red in color, when seen in red light appears to be bright red. These are the small experiment of the primary color, secondary color, and mixing of light, and how we are able to see the things of different colors in white light while the other colors are observed in it. You can easily perform this experiment at your home, and you can able to get it for understanding. So with this, we have completed our physics syllabus for half yearly, and we will soon start our revision of physics also. So thank you.